Hello and welcome to QLab. In today's video we're going to be doing something a little bit different. I'm going to be showing you how I'm building a little piece of apparatus or equipment to carry out some experiments in the future. Now over here I've got quite a grotty looking beaker with some iron complexes in it. So it's iron, the metal, Fe on the periodic table, and I've been coordinating it to some ligands. And ligands are just species that can dissolve or help coordinate up a metal species, but I've been having a bit of problems with it. And one of those things is that some of these metal complexes, they react with air. They can react with oxygen in the air. Now, in a laboratory, we can deal with that quite easily, where we can just use nitrogen. Have a nice dry nitrogen atmosphere, or argon, because it's not very reactive. But I'm going to show you today, using this apparatus, how we can set up a system where we can work under carbon dioxide. So we can get rid of all the air in our system and replace it with carbon dioxide, or displace it, I should say, because you're pushing it out. Now, it should be stated that obviously we're working with carbon dioxide and we can't breathe carbon dioxide, so this experiment requires some care and plenty of ventilation. I've got windows open at the side, so it's good and airy here. And also, I'm using glassware for this because I have it and it's nice and it's useful, but you can easily set this up using bottles and little pieces of tube connecting them, because the area that we're going to make so that it's under an inert atmosphere or under the carbon dioxide is this little chamber here. Now we're not going to do anything particularly sort of risky with that chamber at the minute. We're just going to explore how this apparatus works. And what you're going to need is some vinegar. I've got it here in a little conical flask, and some bicarbonate of soda, which I've got here at the back. Now we'll zoom in and have a look. So let me talk you through this apparatus. Now, firstly, we're just going to look at this front bit here. What I've got is we're going to have carbon dioxide come in this direction, and it's going to come in and it's going to flush the air out. I'm going to keep this tap open. You can tell the tap's open because this is parallel with the tube. And once I've flushed this system, so I can hear it hissing out of here a little bit, I'll close this tap, and this balloon should start to fill with carbon dioxide. Now that acts a little bit like a reservoir, because if I ever need to cut this system off from the carbon dioxide supply, I don't want air to just rush in. So if we have a balloon of carbon dioxide, it'll put a positive pressure. That means it'll keep, like, some of that carbon dioxide will rush out, and it will keep whatever's in here under a carbon dioxide atmosphere. Now, this is going to get attached to this back round bottom flask here, where we're going to generate the carbon dioxide. Now, I did want to originally use this tap to control the flow, so that I could switch it off and isolate the system, so that we're not losing any carbon dioxide, but it's staying under carbon dioxide. But this tap is seized really bad. I do need to fix it, but a quick fix at the minute is to just use a little kitchen clip on this plastic tube, and I close that up, and it should really reduce that flow a great deal. Now let's have a little talk about what's going on in here before we do it. Now I've got some sodium carbonate in here, and when I add my acetic acid, well, I'm going to get sodium acetate generated in here, but crucially, carbon dioxide is going to get given off. You may have seen this in like a volcano type experiment before. So if I add a little bit, let's see what happens. See that fitting? So if we pop that on there, oh, we want to open this tap so that we know it's flowing all the way through. I'm actually going to add a little bit more acetic acid to this. can't hear the flow through here, but I know it must be flowing because it's bubbling here very vigorously. And if I close this tap, you can see the balloons moving because it's starting to fill up with carbon dioxide. Ooh, I should maybe add just a little bit more. Oh, there we go. Excellent. You can see it's starting to fill up. I'm going to open this tap a little bit. If I put the microphone near, you'll be able to hear the flow. So we've got a flow of carbon dioxide coming through. So what we can do is we can use this to control the system we're working in. So now if I close that valve and fill this up, our balloon's going to fill up. It's got nowhere else to go now. So if we put a little clip on here, oh, it's pushed it out. That's something as well. I need to put some clips on here. There's plenty of improvements to make with this system. Plenty of improvements. Now you can see that there is still a slight flow, but it's much more controlled if I have the clip on. And then what I can do to stop it pushing out the valve, I can have it slightly open here. Oh, let's close that off now. We can see it's holding it really nicely. Now, is there a way that we can test that we've got carbon dioxide present in this system? Well, yes, there is, and let's have a look at that. So what I'm going to do is I'm going to take a lit match and hold it in front of this little valve. Let's just make sure everything's nice and tidy. And we'll see if it extinguishes. There's my lit match. And we'll open up this valve. Did you see? So we know now that this chamber here is completely under carbon dioxide atmosphere, or at least that there's not enough oxygen in there to keep a flame burning on a match, which is fantastic. It means I can carry out reactions in there, or possibly crystallize certain things that are sensitive to oxygen and not worry about them reacting with the oxygen in the air. Now I should mention here, this setup can do with a lot of improvements. I know that. But also, if there's any chemists among you, you might know that carbon dioxide can be used in reactions as well. And that's both a pain when you don't want it, but it's very exciting as a way to capture carbon dioxide as well. Right, well, thank you so much for watching. We're going to use this in some future videos. I have to admit, I'm moving house at the minute, which is why everything's a little bit manic. I thought you'd like to see some of the experiments I'm going to be working on. And I know this is a bit of an advanced one, but I'm hoping that we can start to explore some really exciting science that's quite cutting edge, just using relatively simple setups. So, thank you so much for watching, and hopefully I'll see you in the next video.